the rest of the sections, we're going to have to take a bird's eye view because we don't have much time left in the semester, right? So we are going to look at lesson 3.9, and we're going to determine whether two variables have a linear relationship. We're going to calculate the line of best fit for a set of data. And quite frankly, you can either use your graphing calculator if you have one, or Desmos. Now, Connect Math has a video. If you have a graphing calculator and you want to do your line of best fit there, then you will want to go into Connect Math, again at section 3.9, and look for the video that shows you how to find the line of best fit. And then interpret the correlation coefficient for a data set. This correlation coefficient is basically going to tell us how well that our line that we come up with actually models the data. Okay, so more on that later. So in the class portion, they're basically asking us whether or not you think two quantities are likely to be related numerically. And so 1A talks about dollars spent by a political candidate and the number of votes he gets. Well, generally, if someone spends a lot of money on an election, they get a lot of votes, and that used to be pretty much the case. I'm not sure we're finding that to be as true in this day and age, but generally money is related to how many votes that a person gets. For example, if I try to run for office, I'm not, because I don't have a lot of money, I don't think I'd get a lot of votes. So we could say that probably they're numerically related. So B, an adult tests subject's height and IQ. My 6'7" husband would say, oh yes, they are definitely related, but I think most of us understand fully that how tall you are or your IQ has nothing to do with how tall you are. Okay, let's look at the next page here. Sorry if that makes you a little sick. A person's height and shoe size. Well, I think generally the more data that we gathered here, I think we could find that the taller the person is, generally the bigger the feet. That's not always going to be the case. I remember, well, you would need a lot of data points, right? Because we did this particular experiment for one of my classes, and it was weird. Just about everybody had the same size of foot. So it's kind of hard to find any kind of correlation there. All right, D, the age of a car and its resale value. Well, for most cars, the older they are, the less value they have. Again, we're not talking about classic cars here. We're talking about your general car that you buy to drive, okay? All right, so is there a relationship between the total fat in a fast food burger and the total calories? The table here lists calories and fat information for a standard hamburger at a variety of fast food restaurants. Begin your study of this question by drawing a scatter plot based on the table. So I'm going to go ahead and do that right now. I will pause. I know you know how to plot points, so let me pause this. Okay, this is what my scatter plot looked like, and no doubt you would look at that and say, I don't know what kind of relation that would have because the points seem to be a little bit scattered, but what they're trying to get across in this particular section is it looks like even though it's not a perfect fit, oh gosh, pretend that was a little bit lower there, that it looks like there's a linear relationship between the total fat that a hamburger has and the number of calories it has. So number 3 asks you to do what we just did. The points on your scatter plot don't form a straight line, but there should be a linear trend you can observe. Use a straight edge to draw a line that you think looks like a best fit for your scatter plot. Note that it's possible that the line that fits the data best doesn't go through any of the points. Now, number 4, they asked us to identify 2 points on the line of best fit that you drew on your scatter plot and use them to find an equation of a line. So we're not going to do that right now. So those of you with a graphing calculator, here's the step-by-step instructions for you to be able to find the line of best fit for those points. Not perfect fit, best fit.